Here is our steam drum. Rotate it for a moment. You can see there, it's got that long cylindrical shape that we saw before. The connections on this design are, however, a lot more realistic because we've put more effort into designing this particular steam drum. The steam drum is located above the main parts of our water tube boiler, above the furnace walls and the headers. Here is an example of a steam drum. You can see that it's long and cylindrical in shape. Before we have a look at the internals of a steam drum, let's have a quick look at the basic installation as seen here. We've got the steam drum at the top of the boiler. We're going to send, using these pipes here, there's actually 6 of them in total, feed water down to the base of our boiler. And then once the feed water reaches the base of the boiler, just going to angle this correctly, it's going to flow into these manifolds here and then up through these pipes here, which make up the furnace walls. We have our front, rear and side furnace walls, up into the wall headers, and then we're going to distribute that water steam mixture back into our steam drum. The semi-clean steam, for lack of a better word, the steam that's still slightly wet, is then going to pass through this scrubber here, and the scrubber is going to help us separate the water from the steam, or the water, which is liquid, from the steam, which is a gas. It does this by providing a tortuous flow path, a flow path that causes water molecules to impinge upon our scrubber surfaces. This is actually just a single mesh screen. What you'll usually see is that there will be many mesh screens combined together, and the steam can flow through these mesh screens and out of our steam discharge pipe, which is here. You can see that is where we would feed our chemicals in. The pipe itself has a series of holes that allows us to dose chemicals into our boiler feed water system, and we'll spread those chemicals out evenly throughout the entire length of our steam drum. It's quite turbulent within the steam drum as well. There's a lot of fluid moving in and out of the steam drum, and that helps us to mix up all of those chemicals, the chemicals we need to ensure we don't get corrosion on the inside of our heat transfer surfaces or within the system itself, to make sure we don't get scale build-up or to reduce the likelihood of that occurring, etc.